Kinematic equations. In kinematic equations, suppose the condition is given that there's no acceleration, it simply means A equal to 0. Then in that case, you have only one possible equation for the motion. That is displacement equal to velocity into time. This is the only equation that could be used by you in uniform motion, or you might say the motion without acceleration. If there is acceleration, what is acceleration? Let me revise it first. You know, this is the rate of change in velocity, but this might be written this way also. How is it possible? You see, in one step you can manage this. This is dv upon ds. I have multiplied and divided by ds. What is this? This is v. Then it becomes A equal to v dv upon ds. You see, in the numerical problems of applied nature in mechanics, sometimes you come across a problem in which the acceleration is given in terms of distance, not in terms of time. So in that case, you can refer to this relation A equal to v dv upon ds. I mean, it's not in terms of time. Now, what are the equations of motion? Basically, there are 4 equations of motion. In almost all the equations, you are having A. What is A? That's a constant acceleration. So one must emphasize one very condition, that in all these equations, acceleration must remain constant. This shall be assumed that only then you can refer to these equations. These equations are v equal to u plus at, s equal to ut plus half at square, v square equal to u square plus 2as, and similarly this equation st, that is u plus half a 2t minus 1. What is this st? This is the distance traveled in tth second. Tth second means 4th second. You see, this also creates some confusion in mind. Start from 0, 1, 2, 3, 4, 5. What is 4th second? 4th second will start when 3rd second will be over. This is starting 4th second from here. 4th second is this one. Similarly, when you say tth second, it simply means tth second will start when t minus 1 will finish. And what will be 4th second from 0 to 4? This would be 4th second. So when somebody says distance traveled in t second, that's represented by s. And distance traveled in tth second, that will be represented by st. This would be st, whereas this will be given by s. This is the basic difference between s and st. Before we proceed, we must revise this condition again, that while using this equation, we should make sure whether the acceleration is constant or not. Acceleration is constant, only then you can use these equations. You see, st relation will be parabolic. If there is acceleration, st relation will be parabolic. And if you go ahead with one very condition that u is equal to 0, then in that case u plus at, from here you get s proportional to t. St relation will be, if a is constant, st relation u0, sorry, this is v equal to at, vt relation will be straight line, because here you see v proportional to t. S will be equal to, first term goes to 0, s will be proportional to t square. This is going to be a parabolic relation. When one quantity is squared and one has single power, it's called parabolic relation. Similarly, with third equation, you have the first term 0, and this is v square and s. Now square is that of v, so you'll be having a parabola that will be going away from v axis. This is also a rule to remember. if in parabolic relation you find the square of a variable quantity, the graph of parabola shall recede, shall go away from that very axis. Because here v is squared, so the graph is going away from velocity axis. And then finally, have a look at these graphs. You see, between velocity and type, on the basis of this first relation, it's a linear relation. Between s and t, on the basis of this relation, second one, ut plus half a t square. This is a parabolic relation. And when somebody says the acceleration is constant, obviously with time they will be having a straight line graph. And these equations apply to linear motion only. If it's going to change the direction, then in that case you need to apply vector with these terms. Then these equations take the form of vector equations.